router here. It needs to query the corresponding routing table. Help us with data forwarding. This process is called the routing process. When the host is actually accessing now, we'll go to the gateway first. The configured gateway is 10.1.1.254. It looks for 10.1.1.254. Let it help itself to find this 172.16.10.1. On the contrary, if they are on the same network segment, host A will not find the gateway. So after the IP layer is encapsulated, after the source IP and destination IP are determined, actually, the most critical decision is the encapsulation of the second layer. After 3 layers of encapsulation, we will definitely check whether the source IP and destination IP are in the same network segment. If in the same network segment, it means that the second layer is the address of the encapsulated peer. If not in the same network segment, it means that the destination MAC of the second layer encapsulates the address of the gateway. Here on the 3rd floor, as long as 2 people are on the same network segment, layer 2 encapsulation is the peer. If not in the same network segment, layer 2 encapsulation is the gateway. This is a basic logic of data communication. Okay. Next we review ARP. Find the MAC of the next device through the cache of ARP. That is, if I've sent the corresponding request before, there will be a MAC with a gateway locally. The cross-network segment is actually sent to the gateway. If not found now, host A wants to send an ARP request to request the MAC of the gateway. These we have learned in the last lesson. Let's look down at the 2-layer packaging. That is, encapsulation of Ethernet, purposeful MAC here, source MAC, and type. There will be a field in type. Indicates that the upper layer is the IP protocol. For the current overall data, the MAC of the gateway and the MAC of the peer will fill in here. The source MAC is always the host's own MAC. This is always the case when host A sends data. The MAC of the gateway will be encapsulated here. Then let's make a brief summary. When the data is sent as a whole, just like host A sends data to host B, let's first analyze the 4 layers. Suppose a port 1027 is written locally. The host accesses port 80 of the peer to access the web service of the peer. Then when the final peer replies to the host, it is from port 80 of the peer. Reply to port 1027 of the host. This thing can't be changed. The host accesses the web page of the peer. Of course, the web page on the other end will reply to the host. The local host is the peer to access on port 1027. So when the peer replies with data, port 1027 cannot be changed. If change, the host cannot find the service corresponding to the request just initiated. So when performing data communication, source IP and destination IP, the source port and destination port are only exchanged, but not modified, including forwarding no matter how many devices in the middle. It cannot be modified during the entire data transfer process. The port number will not change. Secondly, let's look at 3 floors. In the 3rd layer is the IP. The host's 10.1.1.1 accesses the peer's 172.16.10.1 per arrival to a device. Must be queried on this device, corresponding to the appearance of the destination. Although we haven't gone into detail. But first of all, you must know the principle. Certainly. The same is true for reply packets. Let's think about a question first. Port redirection. Will the ports be modified? The analogy we just made. You can think of it as if you are sending a courier. Let's say I'm in region A. I want to send a courier to area B. Then my courier. Recipient and sender information. It cannot be modified in the middle. Once modified. When data is sent over. That is. When the package is delivered. Peers have changed. Data communication. I also told you in the first class. The difference between a MAC address and an IP address is that the MAC address is like a transit node in the middle. Those transfer stations are often changed. When host A is sending data, the current destination MAC is the MAC of the gateway. After the request, actually from the local MAC address AA, send to gateway MAC address. But when the router assists in data forwarding communication, router and host B perform data encapsulation. The package is the MAC of the 0-1 interface. Send to peer. Here is BB. Of course. ARP requests and replies will also be performed. The router receives the ARP request. It replies to host A with its own address. Query routing table. This is a direct route. It will also send. When sending, the route also has to request the MAC of host B. You will find, when encapsulating data, the MAC address encapsulates the destination MAC of the current data. Since the working range of the MAC address is under a broadcast domain, different interfaces of the router are different broadcast domains. That means, once the data crosses the router's interface, the MAC address encapsulation will definitely change. Because the MAC address of the second layer actually work under a broadcast domain, or work on a link. Then in here, every layer 3 interface passing through a router. That is, the interface with IP is now configured. It's all MAC. Every interface. When we finally go to send the data, the second layer will be repackaged. Then this encapsulation process. It will become the source MAC and destination MAC on each link. It will change. So everyone should know. When data is packaged, the fourth layer is always the same. The third layer is always the same. The second floor is always changing. Broadcast domain. Each link crossed. Each layer 3 interface spanning the router. The MAC address encapsulation will change. Then when the whole is sending data, IP and MAC always work together. IP achieves a positioning under the global. MAC is accurate to each link. Complete accurate forwarding. This is a synergistic relationship between them. Okay. Here's a recap of what we did in the last class. Next we're going to talk about routing. To us. Have an autonomous system. In the future, you will be in the CCNP stage. When you come into contact with the BGP protocol, we'll come into contact with the concept of autonomous system. The autonomous system was originally a concept in BGP. Since the concept is so useful, so it was taken out separately, including when we talk about dynamic routing protocols later. We'll also differentiate. It is also defined by the autonomous system. Scope of different dynamic routing protocols. You have to be clear. This is a concept in BGP. But this agreement cannot be discussed in the NA stage. This thing involves the problem of the overall networking architecture. Without exaggeration, many students who won the IE certificate may not be able to know what an autonomous system is. So let me give you a simple analogy. Let you first understand this concept simply. The abbreviation of autonomous system is called AS. It's a concept on the web. We must be inseparable.